Continuing the problems from motion in one dimension. The sum and the difference of two vectors are equal in magnitude. Prove that vectors are perpendicular to each other. So magnitudes are equal. So let's write that equation where we know the magnitude of two vectors when the angle between them is given. So let us say the angle between the two vectors is theta. So it's given a plus b is a minus b. So this is equal to this. This is 180 minus theta because of angle between a and b is theta, and angle between a and minus b is 180 minus theta. So squaring both sides, we get cos theta is equal to 0. That means theta is equal to pi by 2. Prove that vectors this and this are perpendicular to each other. So if two vectors are perpendicular, then their dot product is 0. So that's what we'll do. Take the dot product and then it comes out to be 0. So you can directly write this as the magnitude of multiplication of the constant which is alongside I caps. So 1 into 2, which is 2, plus 2 into minus 1, which is minus 2, plus 3 into 0, which is 0. So gives 2 minus 2, which is 0. So this we studied in vectors before, that the dot product of two vectors written in IJK form is ax bx plus ay by plus az bz. Explain with the help of vector diagram that magnitudes of resultant of two equal vectors can be equal to each of them. So if these are the two vectors a and b, so they are of equal magnitude, it's given. So just move around. If you move around this b vector, at some point you will see that if it is here, then this a vector plus b vector, this length is same as this length is equal to this length. So it's an equilateral triangle. So vector sum forms a triangle. So when the three sides of the triangle are equal, then a plus b vector, the magnitude of a plus b vector is same as either of a vector or b vector. Now what will be the magnitude of the difference of the given vectors? So here this is a and b, and angle between them is 120 degree. So if we extend it a here, you will see that the angle between a and b is 120 degree. So now what is the angle between a and minus b? So minus b will be somewhere like this. So this angle will be same as this angle, which is 60 degree. So angle between a and minus b is 60 degree. So what will be the magnitude? A square plus b square plus 2ab cos 60 degree comes out to be a root 3. Here, when we were doing the a vector plus b vector, when angle between them was 120 degree, then the magnitude was coming to be just a. So you can see it from here, it will become a square plus a square plus 2ab cos 120 degree. Cos 120 degree is minus half. This will become minus ab. A and b are same, so it will become minus a square. A square will get cancelled. It will become b, and in this case obviously a is equal to b. So when the angle is 120 degree and a is equal to b, then this comes out to be just a. And if it is 60 degree, then it comes out to be a root 3. Two vectors are added. Prove that magnitude of the resultant vector cannot be greater than a plus b or smaller than a minus b or b minus a. So whenever we are talking about magnitude, just you can write this equation directly, and it will say that vector sum of a plus b vector will have a magnitude of a square plus b square plus 2ab cos theta. Now what is the maximum value of a vector plus b vector? Because we are supposed to find the limits of this resultant vector, it cannot be greater or smaller. So let's see when this quantity is maximum or minimum. These two are squares, cannot be changed, but here theta is the variable, and for maximum a plus b, theta cos theta will be 1, and for minimum value of a plus b vector, cos theta will be minus 1. So when cos theta is plus 1, this becomes a plus b, a square plus b square plus 2ab, which is a plus b, and when it is minus 1, then it becomes a square plus b square minus 2ab. So it is the magnitude of, the whichever is bigger, a minus b or b minus a. So now diagrammatically you can see when theta is 0, then the vector sums will be just added like this, and resultant vector will be something like this. And in this case, when they are in opposite direction, then resultant vector will be just like something like this. So a plus b vector is maximum when the angle between a and b is 0, and a plus b vector is minimum when the angle between them is 180 degree. Or when it is 180 degree, then your cos theta is minus 1. For two vectors, if a plus b is c and a vector plus b vector is equal to c, and magnitude of a plus b is also is equal to c, then prove that a and b are parallel to each other. So it's given a plus b vector is c vector, and again if we are talking about the magnitudes, so we can write our equation for magnitude, and if the angle between a and b is theta, then a plus b is a square plus b square plus 2ab cos theta, and he is saying that it is same as a plus b. So this is the magnitude of c vector, and this is just a plus b. So squaring both sides, we'll see a square plus b square plus 2ab is equal to a square plus b square plus 2ab cos theta, which gives cos theta is equal to 1, because cos theta is equal to 1, that's why these two will be same. That means theta is 0 degree. So when theta is 0, a is parallel to b. For second part, if a plus b is equal to c and a square plus b square is equal to c square. So again LHS will be a square plus b square, okay, here in this case RHS, and that is equal to c square, and a plus b is c, so magnitude of a plus b is magnitude of c. Magnitude of a plus b is this, which is equal to magnitude of c, which is c square, which is equal to a square plus b square as is given in the problem. So this implies that actually this will be just c, and is equal to root of a square plus b square. So when you square both sides, you will get cos theta is equal to 0, that means theta is pi by 2, that means a and b are perpendicular to each other. Three vectors are such that a is equal to b plus c, and the magnitudes are 5, 4 and 3. Find the angle between a and c. So again we are talking about magnitudes. So we say a is equal to b plus c, so a square is equal to magnitude of b plus c. If the angle between them is theta, it will become b square plus c square plus 2bc cos theta. Let's replace these values from here, and we'll get 25 is equal to 16 plus 9 plus 2 into 4 into 3 into cos theta. So this gives cos theta is equal to 0, that means theta is equal to pi by 2, therefore it is a right angled triangle. So the angle between b and c is 90 degree. So if this is b, then this will be the c, so angle between b and c is 90 degree. So this will be your b plus c, which is a vector. So he is asking the angle between a and c. So this is a and this is c, so you can translate a like this. So this is the angle he is asking, the angle between the a and c, which is same as this angle alpha. And in a right triangle we can here say that cos alpha is equal to base upon hypotenuse. So in this case base is b, which is given as 4, hypotenuse is a, which is given as 5, so it is 4 by 5. So alpha is 37 degree, and alpha is not the angle which we need. Alpha is not the angle between a and c actually, that is angle between a and c is 90 minus alpha. So the angle between a and c is pi by 2 minus alpha, equal to 53 degree. So this was the theta, which is the angle between A and C, and this alpha is same as pi by 2 minus theta, as you can see here. So if I zoom it like this is C, this is A, so this is theta, angle between C and A, and this is alpha, which is this angle, and this is also A. If A vector is this and B vector is this, then determine the angle between A and B. So it can be done simply with our dot product. So A dot B is AB cos theta, so cos theta is A dot B upon A into B. Dot product of these two, minus 2 into 3 plus 2 into 6 plus minus 1 into 2, divide by magnitude of A into magnitude of B. So magnitude of A is this square plus this square plus this square ka whole root. Magnitude of B is again root of this square plus this square plus this square. So solving this, you will get cos theta is 4 by 21. So theta angle between them is cos inverse 4 by 21. Using the properties of scalar product, show that for a triangle of side A, B and C, cos beta is A square plus C square minus B square upon 2AC, where A, B, C are the magnitudes of A, B and C respectively. So again we are talking about magnitude, so we will write our cosine law, and also we are talking about scalar product. So scalar product is same as dot product. So in a triangle A, if this is A and this is C, we can say A plus C is equal to B vector, and if this angle is beta, then this angle is pi minus beta. So pi minus beta is the angle between A and C. It's not beta, it's actually pi minus beta, angle between A and C. So we can say A plus C is equal to B vector, vector sum, simple, and now we'll equate the magnitudes on the both sides. So magnitude of this will be A square plus C square plus 2AC cos pi minus beta is equal to B square. So cos of pi minus beta is minus cos beta. So this will give you cos beta is equal to A square plus C square minus B square by 2AC, which is what we need to find. Proof. Find the angle between F, force and displacement D, and also find the projection of force on D. So when you are given a force and displacement, the dot product of F and force and displacement is actually your work done by that force. But here we are not asked to find the work done, and we are just simply asked to find the angle between them and projection of force on displacement. So angle we can again find from our dot product. Cos theta is F dot D upon F into D. So this gives F dot D is 3 into 5 plus 4 into 4 minus 5 into 3, divide by magnitude of F into magnitude of D, comes out to be 8 by 25. So now the angle theta between F and D is cos inverse 8 by 25. So we need magnitude, now we need the projection of force on D. So it will be F cos theta. This is the projection of F on D. So F cos theta is equal to magnitude of F times cos theta. Magnitude of F is 50, we can find it from here also. We already find that here, it is root 50 times cos theta we found here 8 by 25, comes out to be 8 by 5 times root 2. Now here if we are supposed to ask the work done by this force, that will be actually force into D into cos theta, that is dot product. So this would have come out to be 8 by 5 root 2 times displacement magnitude, which is also in this case root 50, times cos theta. So it will be root 50 into 8 by 25. That would be our work done. I and j are unit vectors along x and y axis respectively. What are the magnitudes at directions of the vectors I plus j cap and I. What are the magnitudes of directions of the vectors? Magnitude and directions of the vectors I plus j and I minus j. So magnitude will be just under root of their square of their values of I and j. In this case 1 square plus 1 square, root of that, which is root 2. Same for I minus j also. Direction, you can think it pictorially. If this is I, this is j, then I plus j will be 45 degree in positive direction, and I minus j, if this is I, this is minus j, this will be like this. So this direction you can also find by our conventional way. So let's say I plus j is making theta angle with the positive x-axis. So we can say cos theta is equal to I plus j dot I upon magnitude of I plus j times magnitude of I. So magnitude of I is 1, magnitude of I plus j is root 2. So this comes out to be, and this dot product is just 1. So 1 by root 2. So that means theta is making 45 degree with positive x-axis. So this vector I plus j is making 45 degree with positive x-axis. So it can be either here or here, like this. It can be either here or here. Now again cos alpha, which is the angle it makes with the positive y-axis, we calculate that, and that also comes out to be 1 by root 2. So with positive y-axis also it has to make angle 45 degree. So only the center one will satisfy both the conditions, where it has to make 45 degree with the x-axis as well as positive y-axis. So eventual direction of I plus j will be in northeast direction. Similarly, you can find for I minus j also, you can take a dot product of I minus j with your I cap and minus j cap, and then you will find out that both of them are making 45 degrees with this vector. So that means the only direction which is valid is in this direction, which is southeast. A is this and B is this. Determine the magnitude of A and value of A dot B. Magnitude of A is simple, just under root of 3 square plus 4 square, and value of A dot B, so multiply this into this, 12 into 3, 36, plus 4 into minus 5, so it is minus 20. So magnitude of A dot B is 16, magnitude of A is 5. Find a unit vector parallel to the resultant of the vector A and B. So we are supposed to find a unit vector parallel to the resultant of the vectors A and B. So resultant of vectors, just find that first. It will be A plus B, comes out to be this. Let's call it C vector. So this vector has to be parallel to the resultant vector, parallel to C vector. So we know that C vector can be represented in terms of the unit vector in its direction as magnitude of C vector times, let's call this C cap. You can call it any other by any other symbol also. You can call it A cap, B cap, C cap, but just for the sake of clarity, that this C cap is a unit vector in the direction of C. So let's say C vector is magnitude of C times C cap. So C cap is C vector upon magnitude of C vector. So we already know this is C vector divided by magnitude of C vector. So it comes out to be this quantity. So this is the unit vector in the direction of C vector, which is the sum of the vectors A and B. Find the scalar and vector products of two vectors A and B. So scalar product is pretty straightforward. 3 times minus 2 minus 4 times plus 1 plus 5 times minus 3. And for the vector product, it can be done with the matrix multiplication. So you take this quantity first, you write I cap times, you do this first and then this. So minus 4 into minus 3, this 12 minus 5. Now for second, we add a negative in first of that, in front of that. So it will be minus j times 3 into 3 minus 9 times 3 into minus 3 minus 9 minus 5 times minus 2. So minus and minus will become positive, so it will become plus 10. and this is again plus, so plus k cap times 3 into 1 minus 4 into minus 2, so those two negatives will get cancelled, so it will be k cap into 3 minus 8, which will give you 7 I cap minus j cap minus 5 k cap. So once again, for I we just write here as positive and we do this multiplication minus this multiplication. For second term we add a negative first and then we say this multiplication minus this multiplication. So this order of multiplication is same. First it starts from the left top and the bottom right, then top right and bottom left. So when we are doing for I, start with top left minus 4 into minus 3 minus this. For j, 3 minus j, 3 times minus 3 minus 5 times minus 2 plus k again 3 times 1 minus 4 times minus 2. This is the answer. Find a unit vector perpendicular to both the vectors a and b. So if you do the cross product of a and b, you will get a vector which is perpendicular to both a and b. So we can do it again with the matrix multiplication. I cap times minus 4 minus 4, so minus 4 plus 4, minus j times 4 into 3 12 minus 4 plus k cap into minus 6 minus 2, so minus 6 plus 2. So this should be actually plus k cap times 3 into 2 minus 6 minus 2, so it should be minus 8. So this should be minus 8 j cap minus 8 k cap. Now this vector is parallel to minus j cap minus k cap. So unit vector in this direction will be the vector divided by its magnitude. Comes out to be minus j cap minus k cap by root 2. So this is one unit vector which is perpendicular to both a and b. The negative of that will also be perpendicular to both a and b. So this is the correct answer, and j cap plus k cap divided by root 2, this is also correct answer. So if a is like this and b is like this, then this vector coming out of the plane might be j plus k by 2, and the one which is going inside the plane, that might be minus j minus k by root 2. So both of them are perpendicular to both a and b, so both answers are correct. So you would have got this answer if you would have done b cross a instead of a cross b, because a cross b and b cross a are completely reversed in their directions, even though they are same in magnitude. Find a vector whose magnitude is 12 and which is perpendicular to each of the vectors a and b. So again it has to be perpendicular to both, so let's do the vector sum first. Then we can find a unit vector in this direction just like we did before, and then we will multiply that unit vector by 12. So we will get the vector whose magnitude is 12 and it is perpendicular to both of these vectors. So a cross b gives us this matrix multiplication, you can get this, and to simplify it you can say it is parallel to this vector. So you just take the 4 out. Now the required vector is c cap times 12. If this is c vector, and we can find a unit vector c cap in direction of c using this, and then multiplying that by 12 will give our required vector. So what is c cap? It is c vector divided by magnitude of c vector. So it is c vector divided by magnitude of c vector times 12. So comes out to be 4 I cap minus 8 j cap minus 8 k cap. So incidentally it is same as your magnitude of your c vector and direction also. Find out the area of the parallelogram whose adjacent sides are I plus 2j plus 3k and 3i minus 3i minus 2j plus k. So these are the two sides of a parallelogram, and these are the a vector and b vector, and we are supposed to find out the area of the full parallelogram. So let's divide it into two triangles first, and now we can, if we know what is the area of this triangle, we can just multiply that by 2 and we will get the area of the whole parallelogram. So area is 2 times the area of the triangle. The area of this triangle is half base into height, which is half AB sin theta. Now AB sin theta is the magnitude of cross product of A and B, and 2 and 2 gets cancelled. So AB sin theta is magnitude of A cross B. So when with matrix multiplication, we'll find what is the A cross B, and then we'll take the magnitude of it. So this is the A cross B, and magnitude of that will be under root of 8 square plus 10 square plus 4 square. Comes out to be root 180, which is 6 root 5. The next class will do more problems on this chapter.